is Mr. TG. This is lesson 8.2. Today we're going to be graphing what we're going to refer to as a parent function, in this case y equals 3 over x. And it's an equation that has inverse variation. It's also referred to as a reciprocal function. First, before we get into the graphing phase of this, I wanted to show you what an asymptote is. I defined it for you on your sheets of the notes here. An asymptote basically is a line that a graph approaches. A graph can never cross an asymptote, since this would cause you to divide by 0 in your function. To give you an example what that might be in the first problem that we're going to graph, number 1, we have y equals 3 over x. We know that x can never be 0 in this setting, because if we had 0 put in for x, then we would end up with 3 divided by 0, and that's undefined mathematically. So since x cannot be 0, that is represented by this vertical line right here. X is equal 0 would be considered an asymptote, and we would consider that a vertical asymptote. Also, since x cannot be 0, our output cannot be 0. There's no way we're ever going to be able to get y to be 0, so that becomes another asymptote. In this case, we describe it as y equals 0. Now, sometimes I like to refer to these asymptotes as electric fences. Basically, your line can never cross it, so it approaches really close to those lines but never crosses. So what I want you to do at this stage is to take the points in the domain that was provided in both cases here and substitute that into the function, and then sketch the graph of each of these functions. It will create 2 branches. And when you're completed with this, I want you to hit pause first and then hit return, and I'll have it completely graphed for you. Okay, welcome back. As you can see, I've sketched both of these equations, or this equation. There's essentially 2 parts of the equation, and they're called branches. This is a branch along with the other branch. And what makes these branches are the asymptotes. We would refer to these as discontinuous graphs. They don't flow across the screen from left to right. There's interruptions because of that dividing by 0. But it's a pretty simple task of graphing, and we're going to refer to this as a parent function, as we did earlier. The parent function can be graphed by plotting points. And again, in this setting, this set of points I picked arbitrarily. I put it in for x. You could see the inverse variation occurring. And then when you change it to negative, and by the way, that gives us this branch. And when I put a negative in, it gives me the other branch, which is just nothing more than a reflection of that branch. So hopefully yours matched. But what we're going to do now is take these points and slide them down and show you how to graph this equation on the grid. And what this equation, if you notice, the constant's the same. The only thing that's changed is we're adding 2 to the denominator. Now, with these types of functions, you can translate them by simply looking at how the function is set up. For example, in this case, if we're adding 2 to the denominator, then that's going to translate the function left 2 units. All right, it's not going to translate it up and down. Only if you do something to the denominator will it translate it left 2 units, which puts us right here at h. We call this h equals 2. That would be your vertical asymptote. So our vertical asymptote is going to be falling right in here. Our horizontal asymptote comes to us here. It's plus 0. There's nothing there in front. So that's our k value. K is equal to 0. So we describe this as x equals 2 as the vertical asymptote, y equals 0 as the horizontal asymptote. Now, that is where our new center is going to be. When you look up here at the graph, the only thing that's going to change is our branches are going to translate left 2 units. So what you're going to do, what we're going to ask you to do is copy these same tables down, but instead of copying the x values, subtract 2 from each of the x values, keep the y values the same, and then graph those results. And I'll do that. I'll go ahead and do that, and I'll hit pause. And when you're done, I'll have it completed for you so you can check your work. Okay, welcome back. As you can see in front of you, I've completed the graph after it's been translated left 2 units. So to review the steps to get this graph, the first step is to look at the denominator. In this case, we're adding 2. So we know it's always the opposite. So x, we're going to call this the h value. H equals -2. That's basically how far you go either left or right. If it's plus, we go left 2. If it's right, we go -2. And then k is 0 because there lacks the presence of a number out here. If you want to put a +0, you can. So the only thing we're going to do in this case, since this represents x and this represents y, is we are going to subtract 2 from all our x's. And I did that successfully here. I sketched my asymptotes in. And you can see if you compare the first parent function with your second function, you can see all that's happened is it's been moved left 2 units. Now the last example I'll show you here doesn't move our function left or right, but up and down. The reason for that is nothing's being added to the x in the denominator. So our h value, we call that x or h, is 0. That's because nothing's added here. Our y value, or k, is a -4, which tells me that we're going to be moving this downward. So what we're going to do is create another set of values, table of values, just like, and we're going to go back to our parent function. This one, however, will use the values that we come up with. This function is going to take all your y coordinates, and you're going to just take away 4 from all those y coordinates in the parent function. So you would just simply copy these values down, but take away 4 from all the y values. And that should, if we keep the x values the same, translate the graph down 4 units. So what I would like you to do, of course, is to make 2 tables, subtract 4 from all the y values in your parent function, and then graph. And when you're done, I'll have it completed, and we, again, can compare answers. Okay, welcome back. As you can see, I completed our tables. And where did these table of values come from? They're essentially coming from the parent function. The x's match completely. But what I did, I subtracted 4 from all the y coordinates. 4 from all the y coordinates will generate these new values. The first thing I always do when working with these is I find the asymptotes. The x asymptote, the vertical asymptote, will come to us right here from the x value or the denominator. And since in this case the denominator x is by itself, x equals 0, your vertical asymptote. This number right here will give you the horizontal asymptote, y equals -4. That's the horizontal asymptote. So that gives me my new center. And then when I plot points, I know that they should create branches in the first and these 2 quadrants, and they should be reflections of one another. So hopefully this was easy for you. Now, what I'd like to have you do is watch the Pearson video. And then, when you're done with the Pearson video, I want you to try and complete this page of notes when you're finished. Graph this one. You can see this graph is going to translate left 1 unit or 2 units and not anywhere up and down. List the domain and range, and then do the same for these 2, this problem here. And I want you to study the effect that a negative constant has on your graph and what happens, and then again list the domain and range. So after you're done with the Pearson video will now show you equations that have both translations left and right, and will be a nice summary for you to watch. And also, if you watch this video on time, to start rewarding some of the students that are doing the job that they're supposed to do, you can add 2 points extra credit onto your participation score. So this is 7 out of 5, but please don't share this with any other students. I want to reward the students that are watching this video on time. Thank you, and good luck with the Pearson video. And don't forget to complete these 2 problems when you are finished with the Pearson videos. Good luck, and let me know if you have any questions.